I mean, I don't know what to suggest here, but none of these are calculus based, except maybe the points of inflection. I mean, you do have to use that. Extrema, those are the mins and maxes that you might see. What's hard is I don't know what you'll be asked to know what to suggest here.
Yeah, I'm not sure. I like if it has graphing though, I'm sure that it won't be like you said, because it'll be harder to like
Yeah, so
voice for it.
let me do this. Let me graph it in Desmos and just kind of show you what I'm talking about. You'll have your graphing calculator
Okay.
to but there's only a limited number of things that they can sort of ask here. Here's the sketch of this graph, and you can see there's a vertical asymptote, there's a
Right.
horizontal asymptote, there's a y-intercept, there's an x-intercept. There is no extrema, there's no mins maxes, there's no point of inflection. You might be asking me about concavity, this concave down over here on the left, concave up over here on the right,
Right.
things like that.
Okay. Let me see. Well, then we can skip to number 5, finding numbers.
Okay, yeah, so this is probably the most difficult part of the course. These are the application problems, kind of like related rates. Were pretty difficult before. So the sum is S. Is that what this is?
Yeah.
Okay, so typically you get a number like the next one, but what that is saying is X plus Y equals S, and the product is maximized. So the product, we'll call that P, is X times Y. So the general strategy here in these problems is you're going to write two equations. And again, typically this is a number, like the sum is 50 and the product is a maximum. And then you solve, in this case, you solve the equation. Oops. You solve the equation for, usually it's Y, usually, not always, but usually Y. So in this case, it would be Y equals S minus X. And then you take that and you substitute it into the other equation. So P is equal to X times S minus X, like that. And then you multiply in. So you got SX minus X squared. And then this is what you're going to take a derivative of.
Okay.
So normally this is a number, but since it's not, your derivative is S minus 2X. You set it equal to 0, and then you solve for X. So X ends up being S divided by 2.
Okay.
Which
Yeah.
is weird. Like, again, usually it's like 50 divided by 2, or 80 divided by 2, or whatever it is.
Okay.
And this is the critical point. Now you're supposed to show that this is actually the max, but when there's only one critical point in these problems, it is the max, or it is the min. If you only have one critical point, like you don't have to show it.
Okay. And then, yeah, can we just go through like some of those, like 7, like 9?
Sure. Yeah, any of them. 9 is 7, 9. They're either product or sum problems. Okay, so like in this case, this was a sum, maximize the product. So we can go to 7 next if you want here.
Okay.
So this one says the product is 147. So there's two numbers, X times Y is 147. That's what the product is, 147. That's what that means.
Yep.
Then they always give you another equation, and that's what's called the optimization, or it's the one you're trying to find the min or max of. That's the thing you're going to take the derivative of, not usually the one that's given as the combination of numbers. So the
Okay.
sum of the first number plus 3 times the second number is a minimum. So this is our optimization function. And so sometimes you don't know what to call this, but in this case, we're going to call it the, I don't want to use S, but I guess S is the best. Let me just use Z for the moment. Okay. So the problem with this Z is that it's a function of two variables. And while that is a calculus 3 thing, you are not in calculus 3. So you need to make this in terms of one variable, which means you have to solve this other equation for X or Y. And typically you solve it for Y. So Y equals 147 divided by X. Z equals X plus 3 times 147 divided by X. And this is what you're going to take the derivative of. So it's X plus, what is that? 3 less than 4, so 441 over X. I think that's right. And so now you got to take a derivative of that. So once you get it down into one variable, you take a derivative. So it's 1, and this is power rule. You can think of it as X to the minus 1. It ends up being minus 441 over X squared, like that. You set it equal to 0. And you solve for X. So could you solve this for X for us, please?
Yeah. Negative 21.
And positive 21, right? Plus or minus the square root of 441. So yeah, so let me maybe work through this. You actually want to move the 441 over X squared over. I know if you subtract 1, but then you get both negatives. Actually, that's probably how most students would do this. So you get a -1 here, but then you cancel out the negative. And then you take, okay, 441, multiply both sides by X squared, and then that's where you take the square root of both sides.
Right.
So X is, it's either plus or minus 21, but it does say in the problem, it's only positive numbers. Not every problem that will say that, like you do get negative solutions sometimes to these things.
Okay.
And so that is the answer to one of the numbers. Because typically it's you got to get both. So the product is 147. So if X is 21, then Y is 147 divided by 21, which ends up being 7.
Okay. So we solve for X and then we put it back into the.
Yeah, it's kind of like solving a system of equations. You get one answer and then you substitute in to find the other.
Okay.
So you said maybe go to 9 next. Is that
Yeah. Number 9.
the other thing you can do? I'll point that out here for this one is I know that we're in calculus and you got to take derivatives and all that, but if you were to graph this function, because that's how you did it before, if you were to graph Y equals, and I'll do that for you here, Y equals X plus 441 divided by X. If you were to graph it and get the minimum, look for the minimum, you will not be surprised here to see that the minimum is X equals 21.
Okay.
So that's another way to do it. Like you don't have to use calculus, or if you get stuck on a test and you can't figure out the answer, you can
Okay. Perfect.
do that. So number 9 is a sum problem. And you're always going to write two equations. Two equations. So in this one, there's a sum equation and then a product equation. Would you attempt to write those out for us, please? And for this one?
Yeah. X plus 2y equals 108. And then the second one, we just move the y to one side, right?
Well, you got to write an equation, and I would just use I would say P for product, P equals.
Okay. E equals 108 minus x over 2.
We'll start with just the product. The product is X times
Oh,
Y. And that's what I meant by writing the two equations. That's the first part. Now, you always solve the one that has the numbers in it, I guess, if you want to look at it that way.
right.
So solve this one for Y. Maybe that's what you had already done. Solve for Y, and then put that into this other equation. Maybe that's what you did already. I'm not sure.
Yeah.
Okay, so if you did that, it's 108 minus X divided by 2, like
Yeah.
that. And you have your choice about how about do you want to simplify this? Do you want to graph it? Like, what do you think you would do on a test?
Probably simplify it.
Okay. So to simplify this, you got to be careful. Maybe you treat it as a 54 minus X over 2. You multiply by X, so it's 54X minus 1/2 X squared. So what I'd like you to do from here is take a derivative and then set it equal to 0.
Okay. $54 minus x equals 0.
Right? So set that equal to 0 and solve for X. What is that? Take derivative, set it equal to 0 and solve for X. What does that become?
X equals 54.
X equals 54. Yes. So that's your first number. And then to get Y, you have to use this equation here. So what would Y equal?
$27.
That would good. All right, any questions on that or thoughts?
Nope, that was easy.
Yeah, the first ones are, they really, you do a few, you actually probably did these in a pre-calculus or college algebra class. They're related to the perimeter and area questions, 11, 12, 13, 14. They're essentially the same problems, but they give you a physical situation. So just let me know where you'd like us to go for the next, next couple of problems.
Yeah, can we do 11 and 12 next?
Sure. All right, so the first thing here is they tell you that it's a rectangle. I typically use X along the base, Y along the height, just to kind of be consistent with that. But it doesn't always work. Like sometimes you do switch the variables. to the perimeter in this case is 2x plus 2y, and we know that that is 80. So see, like, just like before, um, we're trying to write an equation with all the numbers in it. Is this okay?
Yep.
All right. And now we're trying to maximize. That's the other thing. You could write the word max area. Area is x times y. And then you always solve one equation for the other one. Or for y, you typically solve for y. And then, well, you put that in the other equation. So if you don't mind, I mean, why don't you try this one? It's just like the last one. Solve that for y, put that in the other one, and come up with the value of x for us, please.
So it's x times 40 minus x.
You have any questions for me on this one or an answer?
I said a equals x 40 times 40 minus x. I don't know if you
Sure.
heard.
Oh yeah, yeah, I did it. So I want you to take the derivative, set it equal to 0,
Oh, okay.
like this. Yeah, just keep going. I mean,
Okay.
this is the standard problem.
So x equals 20.
So what does y equal?
Y was 40 minus x. And then, oh, you put it back in and then, okay. Y equals 1.
You just said it though, 40 minus X, 40
Oh,
minus
40.
20.
40. Okay.
So it is often the case that the answer is a square.
Okay.
It is often the case. Is that all right?
Yep.
Very good. Okay. All right, so the only difference between 11 and 12 is instead of 80, it says P. Instead of 40, it's P divided by 2. And instead of the answer being 20, it's P divided by 4. So like 12 is the generalized case. So we don't really want to do that. We want to do, I mean, I doubt you would get that on the test. That's a more, it's better that you can do like 11 and 13, I guess. But if you really want me to do 12, we can do 12.
No, we could do 13 then.
Okay. So again, this is really similar. So the area X times Y is 49. Right. But the perimeter is 2X plus 2Y. So notice that the area this time is the equation that has the variables in it. Do you see that?
Yeah.
So what you have to do here is you have to solve for Y. Okay. And then you have to put that into this other equation over here and then take a derivative, set it equal to 0, make that your answer. Is that okay? Any questions on that?
No.
Okay, so why don't you give that a try? You're welcome to graph if you don't, like that. Uh,
So the graph looks like so it's going down and then, or yeah, going down and then,
There should be a minimum somewhere. That's
yeah.
what you're looking for.
Because it has a horizontal asymptote and then. How would we be able to tell the minimum on this graph?
It should come down. So what is your equation? What are you graphing? What did you get when you when you solve for Y and put it in for it should be 2X plus 2 times 49
49.
over X.
Yeah.
Yeah, so you got to zoom out, but it should have this kind of thing where you can do a second alpha min on your graph.
Oh, so 7 and 28 and then -7 and -28. That's what it's showing up for me.
So it's the X value that you want.
So 7 and -7.
Well, it'd be positive, right? Because these are lengths. So X is 7.
Okay.
So now that you get X, you got to get Y. So you get Y from probably this equation, 49 over X. And you find that Y is equal to the 7.
Yeah. Okay, yeah. Okay, that makes sense.
Again, it is often a square. The other possibility, so the typical answers in this, just to kind of like, so you can get a little bit of a head start on these, is that typically the answers to these min-max problems are squares. Okay. The other one that you typically see, so like we'll just say 7 and 7. The other ones you typically see is where it's like 7 and 14, where it's double. Or you can think of it as half, depending on how you want to look at it, where the dimensions are half or double of each other.
Okay.
All right. You sure you don't have I know you said a quiz coming up, but it feels like you're kind of at the end of a chapter again for a test.
Yeah, so he does it's like every 6 lessons. So like the first 6 will get a quiz, and then over the entire like the next 12 will have a test. So last week we had over the first 12 lessons, we had a test. So this week we have a quiz, and then next week we'll have a test again.
Okay.
Yeah. So
Where do
this
you
week,
want us to go from here?
hold on, let me look at the homework questions. Just check. $15.
Okay. So because you're going to have multiple choice, you would actually do this one differently with multiple choice.
Okay.
I mean, I can show you how to do it by hand, but the thing is, it's like the answer, the answer will be a bunch of ordered pairs. Like, let's just say one of the ordered pairs was 0, 0. Because we're trying to find the minimum distance, it's faster to just calculate the distance between the points.
Using the distance formula.
Yes, yes.
Yeah.
Having said all that, we can do this by hand if you would like. What would you like to do?
Yeah, can we do that?
Sure. So distance formula is square root x2 minus x1 squared plus y2 minus y1 squared. So the distance formula in this case is, we'll treat this as typically x1, y1. So we'll go x minus 0 squared plus, now instead of y, we're going to use y equals x squared. So we're going to use the x squared for that, which is kind of the awkward of this problem here. Okay, so then you have a choice at this point, which is you can either simplify and take a derivative, or you can graph. And yeah, that's kind of where you're in this kind of weird part of the course where you really probably better off graphing these than what if you make a mistake taking the derivative? What if you don't solve it right, and so on. So then only problem with that is you may not get a point that makes sense to you. Like in this case, it ends up being that it's not like a nice number. So you'd have
Okay.
to reconcile with that with the graph. So if we were to do this by hand, it would be x squared. When you FOIL this, you'd end up getting, well, actually, we don't need to FOIL it for what we're trying to do here. You would then need to take a derivative. So the derivative is, and it looks bad, but some of it doesn't matter. So it's 1/2 square root x squared plus x squared minus 3 squared. This part actually doesn't matter. Then you take the derivative of the inside function. The inside function is 2x plus 2 times x squared minus 3 times 2x, like that.
Okay.
Okay. And this is the part you care about. This is the part you set equal to 0, the numerator. So you'd set this 2x plus 2x squared minus 6 times 2x, which ends up being 12x cubed minus 12x squared. Sorry, 12x, sorry, 12x. And so you got 12x cubed minus 10x, setting that equal to 0. You'd factor out a 2x, so you'd get 6x squared minus 5 equals 0. So x equals plus or minus the square root of 5 over 6, it looks like. Let me see if that's actually correct here, according to the graph. I wonder if I made a mistake. I might have made a mistake. So let me check my derivative. Oh no, this is 4x. That's the issue. That's 4. That's why it's off 4. That's a 2 right there. So it ends up being 5 over 2. Like that. And that looks like it is correct. Yeah. Okay. So what that suggests is there's actually 2 places on there. So in context of the original problem, y equals x squared is a parabola. And here's the 0.03. There's actually 2 places that are the shortest distance, one right, one left. And so these are the x values. And usually they want both the x and the y. So you would say, okay, if x is square root of 5 over 2 and y equals x squared, it becomes 5 over 2 because it's square root 5 over 2 squared, which is 5 over 2. When x is minus square root 5 over 2, y equals minus square root of 5 over 2 squared, which is 5 over 2.
Okay. Yeah, that makes sense. Okay.
Like I said, I would just graph
Yeah, that looks a lot. It
I would do
seems
the
like
distance formula, or you can sort of maybe even graph them and sort of get a, pretty good estimate.
right. Can we do 25?
Sure. Sure. We get there. Yeah, kind of another classic exam question. You'll see. What is going on here? I don't want that. Okay, so it says the rectangle is bounded in here, and what you can't see, what they're trying to show you is that like this could also be a rectangle. Like there's a bunch of rectangles. There's even a thinner one, right? There's a bunch of these rectangles that you could have based on this. So the y value in this case is the height. The height of the rectangle is the y value, which is the square root of 25 minus x squared. The width of the rectangle, or the base, you're going out x, and then you're going the other way x. So you're going 2x. So
Okay.
the area of the rectangle, which we know is base times height, the area of the rectangle is base times height. It's 2x because you got x in both directions, and the height is the square root of 25 minus x squared.
Okay.
So why don't you, well, let me check and see if this actually works first. I was gonna graph it and see if it works, then have you do that. Yeah. Nope. Darn. Okay. So you do have to take a derivative of this. It is product rule. Why don't you give this a try, taking a derivative for us, please?
Okay, so it'd be 2x times negative 2x to the half plus 2 times the square root of 25 minus x squared.
Let me work it out here as well. So it's first times the root of the second. And then the derivative of the inside function is minus 2x plus the second times the root of the first, which is 2. So that divides by 2, so you got minus 2x squared over this, 25 minus x squared. And then it's kind of your choice if you want to, and you do actually probably want to make a common denominator, which you multiply the top and the bottom. So 2 times 25 minus x squared over this. Because it's really the numerator you care about. So you end up getting 50 minus 2x squared on the right, minus 4x squared. And that's what you're going to set equal to 0. Always the
So it'd be plus or minus 5 root 2 over 2.
yes. So that's, I mean, that's the x value. You know, you got to go back and get the y value, which is comes from, you know, here, right here, you know, right that.
So you just sub it back in and then.
And that's, you know, I mean, you probably only have one or two answers with, you know, what you got here. You know, the fact that it's the square root of 25 over 2, you know, 5 over root 2, or, you know, rationalize that to 5 root 2 over 2. I mean, there's only going to be uh,
Okay, perfect. So
All right, maybe time for another problem. As you can see, these are kind of long, depending on.
Yeah, no, that was the last one. We're good. That was
Great.
good.
Okay, so let me go and stop the recording here.